Hello and welcome everyone to our Flex RFID webinar today. I've got Chris Stein with me. He'll be walking us through kind of real world applications in the warehouse. Kind of per the agenda we shared, we'll be focusing on why faster scanning alone can actually make accuracy worse. How RFID and Flex can help with breakdowns in those moments and give you a live look at the latest hardware, some really new exciting developments and some exciting new reductions in cost. And we can talk to you about the Flex Scan Pro. So we have a lot to cover today. With no further ado, I will hand it over to Chris and let him start walking us through the latest and greatest.
Thanks, everybody. Hopefully, everyone's having a good spring. We are having maybe too good of a spring out here in Utah. 70, 80 degrees, a little bit hot for spring, but it's a gorgeous day out here. So, hope everyone's doing good. March is typically a very busy time for our customers. So, we will be recording this to make sure it's available for everyone, but we really appreciate you taking your time to talk about stuff that a lot of people in our industry are talking about. And I get lots of emails or calls that come in about, hey, I want to talk about RFID. And I always want to look at that question and say, what is the problem you're trying to solve with RFID? RFID is a tool and it's a solution, but what are the problems that we're trying to solve to make sure we're solving them the correct way? So a couple of the three main takeaways when we have that conversation, we talk about warehouse managers. We spend a large amount of time tracking down missing items is one of the big things that we hear. A lot of what we go in when we dig into that process is what's really happening is inconsistent warehouse processes during busy times with new users, sometimes like that, makes non-serial inventory items really hard to maintain accuracy. And the speed at which the warehouse has to move and the speed at which sometimes barcode scanning or the warehouse process goes affects that. And we also talk about, had other conversations with customers who are moving in the direction of a more serialized warehouse process, but then there's solving one problem can oftentimes create another problem. So we talk about, man, we're struggling, growing and scaling. We want to add more locations. We want to grow our business, but we're worried about the current processes are inefficient and won't let us grow and scale as well. So those are some of the things that lead to those questions. Well, let's talk about RFID. So the first thing that I want to talk about is the platform itself. Flex is known industry-wide as the domain experts in warehousing and having a platform upon which customers can accurately track their inventory with good processes and the system doesn't break down. We constantly hear from customers who are migrating to our software that competitors' processes don't work, aren't flexible enough in the speed at which they have to work. And warehousing just doesn't work on our current software and looking to improve that. And what I want to emphasize is bad warehouse workflows and processes. Adding RFID on top of that doesn't solve the problem. You get to bad results faster than you could. It doesn't mean you solve the core problems. And so when we look at that, RFID is a tool that you can use inside those best practices. So I always talk about a good prep of a job really starts at the de-prep of the last job. And so we have the ability to free scan in stuff, return from specific manifests. We can do that with RFID in bulk and barcode scanning. Then there's the question of, is it broken? Do we have it put it in repair? If not, does that item need to be placed back in cases, and we're pre-packing our storage containers before we put them on the shelf show ready If so, we can scan that case and container storage processing, fill the contents with RFID or barcode, and get it show ready. Then when we're finally ready to prep, we have a very efficient process to get that gear onto the manifest and onto the truck very efficiently. So if you've already scanned those items into storage containers, you just have to scan the storage container out. Are we scanning these items loose, or are we putting them into cases? If we're using in cases, we can do free pick container scanning and then fill the contents with RFID. If they're just loose, we're just scanning or using RFID. So those are the main areas where we get into these large assets, bulk quantities and stuff, and how we can use RFID in that process. So one of the main things that a lot of people come and talk to us about is we've got a problem with non-serialized inventory. And when we talk about non-serialized versus serialized, these are individual inventory models that we're not tracking on an individual asset level. We have quantities of these items. Typically, these items are lower in individual value. A 50-foot AC cable is not as expensive as a speaker or an LED panel or a console or something like that. But and these items also are typically large quantities. And so we may have 500 of a type of cable or 1,000 or things. And so the overall value is still very high, but the individual value is low. And scanning each of these individual items becomes impractical with your current warehouse staff. And this is where that warehouse process breaks down. Hopefully, when you scan 50 out, you return those 50, and that's the ideal functionality. But as things scale and get busy, that doesn't necessarily happen all the time. And so this was really a practical decision for a lot of customers to make them non-serialized, but it does create downstream challenges. And so for these non-serialized assets, what you lose is a unit level scan history. You lose unit level repair history. You're treating these items as quantities and not as assets. And the biggest thing you lose with non-serial inventory item, and we'll talk about this a lot, but is that autocorrect functionality that we built into Flex that makes Flex so powerful. The ability to, if we skip a warehouse process out of necessity or by accident, if we scan it on the next job coming back in, going out, building it into a case, when things are serialized, we will auto-correct any missed scans and we get our inventory back up into correct locations and availability. So that's what we lose with the non-serialized items. Oops. So taking this into a visual workflow, we've already scanned 50 of a non-serialized item out to a job, and a truck goes to that job and picks it up. So virtually in Flex, we're going to talk about job 1, job 2, and the availability of that inventory model. So with those 50 scanned out on the job, the pull sheet requested 50, we put a quantity 50 out. Job 2, we're going to scan 10 out later on. Right now, with that job out on site, availability shows 0 out of 50. When it comes back to the warehouse, and we've got this cute logo of a thief coming and grabbing 10 of those 50 power cables, or whatever you want to call a non-serialized item, he takes them out of the pile or out of the case because he's got a problem that he's got to send a job out immediately, and he may forget to scan that item in. So right there at that step B, the virtual world of Flex is not shown in the reality world. So 10 have been taken, but the job still shows 50 out of 50. In reality, if warehouse practices were followed, he should have returned those 10, before he took them. So that's the part that was skipped. When we go to step C and he goes over to the other side of the warehouse where he's prepping job 2 and he scanned those 10 out, because these are non-serialized, we can't connect that together. It doesn't know where those 10 came from. So job 1 still shows 50 out. Job 2 shows 10 out. And the only thing that we can do is track those quantities out and in. And the math shows up is we got -10. Something happened and we missed this step, and we can go through and look at our scan records to try to fix that later on. But that's the problem where our availability and our return of job 1 are out of sync with reality. So when we go and scan those items back in, and someone's looking at job 1 and they see 40 cables there, they go and return 40, they're still missing 10 because no one scanned them back in. And so job 1 shows 10 out of 50 instead of 0 out of 50, and availability shows 30 are available when availability should be 40. So that's where this misstep on non-serialized items causes problems. When we move into a serialized world, same thing, 50 are out on job 1. A thief comes and takes 10. It's still virtually out of sync. But the second in step C, when we scan those 10 serialized assets from job 1, and we take those and we are prepping them to job 2, each one of those scans will move an item as returned from job 1 and prepped to job 2 until we have 40 out of 50 are remaining to be returned and on job 1, and job 2 shows 10 out of 10. That step C, it automatically fixes your inventory, your availability. When they finally go to return job 1 and there's still 40 outstanding, they return those 40, they mark them back in. Now job 1 shows 0 out of 50 instead of 10 out of 50. Job 2 is accurate, 10 out of 10, and availability is 40 out of 50. So that's the autocorrect functionality that helps warehouses become much more efficient, where you don't have to go back and fix problems. And so where this starts to happen is multiple jobs and trucks return together, things get intermingled. It's hard to know those non-serialized items. When inventory items are bypassed, that's when that problem gets happen. If gear gets taken directly from show 1 and never gets returned to the warehouse, and they go to a new job, that's where you'll get that inconsistency. If items are taken and returned to a different warehouse, tracking that movement of non-serialized items gets really hard. So that's where exponentially those non-serialized problems comes to bite you. And so the reality is those non-serialized warehouse process skips, those errors eventually require manual correction by a human. And so while we get the benefit of fast non-serialized outbound scans on the front end, and we save time there, we create a time-consuming reconciliation on the inbound scan. So that's where that problem really starts. And so a second effect of this whole thing is, as we're starting to we have to go back and do some calculations and look where processes break down. A lot of times these returns stack up on your busy times. Your real-time availability becomes affected because you're supposed to have it returned by 9 and we're still having problems figuring stuff out. Availability gets affected. And a lot of times what happens is we're starting to put more time on figuring out problems and scanning more items, and quality control doesn't get prioritized if we make that step. And so serialization is a really great thing, and it solves that problem. but then it creates new problems. And so I always talk about serialization is really great for tracking inventory items and knowing where everything is and getting that auto correction, but that causes more scans to get the accuracy correct. More scans equals more labor equals more cost equals less profit. And so higher volume throughput on customers, you get that serialization tax and the labor it takes to process that. And so, again, had a very specific conversation with a company that they've grown incredibly on our product. They want to add more warehouses than they currently have. They want to scale, but they're really struggling to the point where they can't become, they've got to solve the efficiency problem to become more profitable. And so it's a great problem to have. So we had someone raise a hand. Let's stop here and ask some questions and things like that. Jason, can you help me out on that one?
Justin, it looks like you have a question. I think you should be able to unmute and share your question.
If not, type it in on the comments and we can address that later.
Oh, it still says you can't unmute. All right, I am.
Okay. We'll have more breaks.
I'll work on that, Justin. Give us one more minute. So.
Okay. So a lot of this foundational basis problems, moving problems, adding solutions leads us to that conversation about RFID. We've talked in previous conversations, but RFID started back in the 1940s during World War II. The British developed a process and they called it identification friend or foe system. And they were using radar signals to identify their planes. So as planes were coming back over the channel, they needed to find out if those were Allied forces or non-Allied force planes. And if not, we had to go and send planes up to, or the British had to send planes up to take care of that. And so that was the first iteration of radio-based identification of assets. This added and started to be used more commercially in the 1970s. In the 2000s, this is when things really started to take off. UHF RFID was introduced. And one of the main things that happened in the 2000s was standardization in all things RFID. And what this meant is previously, a lot of times, the tags and the readers would only work with one tag, would only work with one reader. They weren't interoperable. They were kind of designing their own specs, and it was kind of the Wild West. So in the 2000s, that's where the standardizations started coming in. If you look out there at RFID vendors, you might see in the UHF area RAIN RFID. This is an alliance, and that's a great example of an alliance of many different manufacturers coming together to write to the same specifications so all readers and tags are interoperable. They want to make sure that they have similar read ranges. And so RAIN RFID is a great example of the standardization in our industry. And they built that for, passive functionality, no batteries on the tags, built for high inventory environments. So speaking of these frequency ranges, there are three main frequency ranges that RFID operate, and they're all under the RFID umbrella, but they are not interoperable. Meaning if I have a low frequency tag and a high frequency reader, they will not recognize each other at all. The top two ranges, low frequency and high frequency range, those are typically used for identification only. They are very short read range. The two most common scenarios that you are using actively on a daily, weekly, monthly basis is tap to pay and uh, hotel card entry or warehouse door entries. Those are all in the high frequency range. They are meant to be short range. You're not meant to be able to take a RFID reader and read everyone's credit card in line. That would be very dangerous. So built into that frequency range is security, and the range is part of that design specs. So anything in the high frequency or low frequency will not be able to be read in ultra high frequency. Many years ago, when the FCC was reallocating specific bandwidth, your wireless microphones was a good example of your old wireless microphones got moved to a different frequency band. Mainly because of Wi-Fi and cellular data, but UHF RFID had to fit into that range also. So there, because it's in a regulated area, that goes into those technologies. So speaking of regulations, RFID is international, and because it's in a range that has to be regulated, different companies have regulated it based on other things in that bandwidth. So you've got the green frequency band and the blue frequency band. Green frequency band is called kind of the FCC range, typically North and South America in general. The European side of things is typically in the 865 to 868 megahertz range. And so UHF is global, but it's not globally identical, meaning the readers that send out the power are regulated on which area they can work into. So as an example, I can't even buy European licensed RFID readers from our US distributor. There are tags that are what are called international, and we'll go over tags specifically, but in that situations, there are certain customers who buy specific tags that if that asset gets moved from the US to the UK, as an example, the different readers on different frequency allocations can activate and read the same tag, and they're specifically designed for that. So, comparing RFID and barcodes. Barcodes require direct line of sight. I'm going to be using some lighting comparisons, but it's like having a spotlight. I've got to focus that spotlight on a very specific person. I'm not putting that spotlight on the whole stage. And so you're aiming a barcode at an individual item and you're processing it one at a time. Radio frequency identification uses radio waves to identify items within a range, and it doesn't necessarily have to be line of sight. It can penetrate certain items or go around different areas. So line of sight isn't necessary, but it definitely helps. And so RFID, I like to compare it to using more of a floodlight. I'm more flooding a specific area with radio frequency to identify it, not a specific focal point. And this allows you to read multiple items at the same time.
Chris, can you maybe talk a little bit just about range and distances? We've got a few questions coming in around like how, what do I need to be aware of to make sure I'm not capturing things inadvertently?
Yep, we will be going over those. We've got specific slides that will go over it. But the RFID power that you can set on your reader is one of the biggest tools you can to, it's like your fader on your console, your old ETC Express console. When you're turning up that fader, you're sending more light out of that floodlight. I would equate that to the RFID power. We can turn that volume or that intensity up and decrease it. And that's one of the great things about this new scanner is the ability, and you'll probably see me, I might be adjusting the power depending upon where I'm working in my workflow and stuff. And so that's how I would talk about that. But we will be talking very specifically about what do you do when you get more than you expected? How do you handle that? What do you get when you get less than you expected? So great questions, and we got you covered on this slide deck. To understand just the process, again, I hope I'm not going too small bite size, but I just want to make sure everyone is on the same page as far as what is actually happening. When we pull that RFID trigger on the reader transmits the energy based on the setting in the reader. The tags harvest that energy that are in proximity and transmit that power to a small IC chip on the tag. That tag reflects back, and technically they call that backscatter, and they send that signal back to the antenna on the device, and it modulates that signal to put the tag's identification in that stream. And then the reader captures that, demodulates that, and converts it into usable data. It sends back 24 alphanumeric characters that then the system processes that. So RFID is transmitted, antenna harvests that energy, turns on a tiny little computer that identifies itself. That identification is read back by the reader. That data is converted and sent downstream to be processed. That's basically what's happening, whether you're using fixed readers or handheld readers. That's the process. So as promised, factors affecting read accuracy. What happens when not all tags are read? Sometimes, do you have your power set too low? So typical readers have settings for how much power you can apply, and typical settings range between 10 dB and 30 dB. One of the great new things about the RFID or the FlexScan Pro that we'll be talking about more, they have one of the broadest range I've seen. They can go down to 1 dB and even expand up to 33 decibels. So that whole concept, what is 10 decibels, 20, 27, 30, like that doesn't equate much. But as you start to use it, the main thing to understand is if you increase from, say, 27 dB to 30 dB, we have doubled the RFID power being transmitted for tag antenna harvesting. If we drop that by 3, we're having it. So if we go from 27 to 33, we've doubled it twice or quadrupled the power. So that's one of the things to kind of in your head understand conceptually what's going on. But when you start to use it, and especially with these new readers, a lot of times I'm adjusting 1 or 2 dB in a normal warehouse flow. I'm not going from, 10 to 30, stuff like that. You'll find a range that you start to work in, and you don't have to adjust it much typically, because we're typically, I'm doing the same workflows, but I may have to double it. I'm going up maybe 3 dB, things like that. But basically, tags must receive sufficient energy and not be interfered with to activate that tag and get that data. Polarization is another concept that people don't really understand. They may understand it, but they may not know what it really is. So just like a microphone, got the old standard Shure SM58. This has a polar pattern that when I'm talking into this, the most sound is captured in front and it's rejected in back. So if you've got monitors in front of you, it's rejecting the monitor, it's getting my voice. Polarization does have similar things with RFID. On this label right here, you will get different read ranges or different read strength on the same power depending upon where your antenna is in relationship to the polar pattern. And so you may not understand it, but you probably understand it. As an example, if a shipping company, say UPS, I got a package the other day and it had a RFID tag on it on the top of the box. And so when they're using RFID, they have their antennas pointed straight down and they've got a conveyor belt with boxes going underneath them to read it. They have a very specific process to make sure we're sending the right signal and the right polarization to get the best read output. So we're not going to miss a box as it goes through that. And so that's one of the things that we don't have the luxury of in our industry that other industries have put into their process. So tags read strongest when they're aligned, but we don't always have that luxury. Misalignment can reduce that signal strength. There are specific type of antennas. People in wireless microphones understand the difference between a flat antenna and a circular antenna. Circular antennas work well with belt packs that might not be perfectly going upright, things like that. So they have similar technology in RFID antennas, and they have specific polarizations to help counteract that polarization process. It won't eliminate it, but it helps reduce that effect. And so what you'll see me doing is a lot of times when I'm reading stuff and I'm not getting everything, sometimes slight movement or orientation changes. We're not changing the power, we're changing the polarization orientation. And oftentimes that gives us that last 10 to 15%. So polarization is a real thing. When to take that and compound that problem, here's an example of I've got 50 RFID tags that are coiled up. They're all pointed differently in the circle and tilting up. So that's a perfect example of this is the worst way to handle polarization, but it's how we do things. And so how do you counteract that inability to orient everything? Power and movement are how you counteract that. Interference is another factor. So line of sight, things in between the reader and the tag, there's two things that are going back and forth if you've got stuff in between it. Power will stop it from getting full power to the tags. The tag has the back splatter and it's affecting it return it. So there's two different things in that way that's going to affect that. So signals can be absorbed, reflected, or blocked by the material type. High density tag environments has a thing called signal competition. It affects the whole signal. So in closed spaces like cases, it can reduce the power sent to the tag and read back. So it is a real thing. And so again, how do we handle that process? Another area that can affect read accuracy, not all tags are read. The tag type you have and what it's meant to be put on in the mounting surface will and can affect the strength at which a read is accepted. So there are certain tags that are meant to be put on metal. There are certain tags that are meant not to be put on metal. And so a standard paper tag, so if you go into Lululemon, they do a stock count with RFID every night. And their labels with their prices and everything and the description of the product on that tag, that has an RFID label embedded inside that cardboard tag. And it was designed to be used on cardboard environment. If they had metal tags, it wouldn't get the same read range and stuff like that. So understanding what tags you're buying and what it's intended to be used on is very important, and that will dictate the read range. A good rule of
Chris, maybe I
thumb.
can jump in quickly. There's a lot of questions around like what tags for different things. I've shared in the chat that, we've done a lot of testing, looked at a lot of vendors, and we do have, specific recommendations for different types of tags for different types of assets. So we'll provide some guidance on that in our
Yeah,
follow-up,
and
but
there's
just know
some
that you
more
can reach out to
information
us.
here in in the presentation. Um,
Great.
but rule of thumb is sometimes the larger the tag, the better the read range. The smaller the tag, the shorter the read range. And that's basically, I've got a bigger antenna and a larger label that can harvest more power, if that makes sense. Also, physical wear, bending, or even impact can degrade or destroy the tag. Early on, we had a manufacturer trying to take labels that they used to put on cables and put a clear area and wrap it around. Oh, that worked great for barcodes. We should be able to take that and put an RFID label in it. The smaller the cable, the more it bent. The more it bent, the more it broke the antennas. And all of a sudden, what you thought you just put on 100 labels on cables, and now they start to degrade and aren't used. So that's just typical stuff. Impacting.
Chris, Chris,
Yeah.
quickly, we had someone here kind of saying, still not seeing how this solves the cable issue, right? If it struggles with large quantities or through cases, my
Yep.
cable is already serialized. Sounds like I would still need to get a scan on every single cable. Can you kind of speak to that?
Uh, we'll speak to it soon. Yeah, we're going to talk
Okay,
very specifically about cables and stuff like
right.
that. So yes, we're very aware that is literally one of the biggest things people come and talk to us about is I'm I don't want these non-serialized, but I don't want to scan them. So yes, we have a great product or a great vendor that we can use. Um, so what happens if you're getting too many reads? So a lot of those last slides were how do we handle if we're not getting enough power, change our polarization, things like that. What happens if we get too many? That's the opposite problem. Sometimes reducing power, adjusting the directional. I'll give you an example in a couple minutes, but sometimes if I've got tags here and here, if I point my antenna away from it, it will reject based on the direction that I'm scanning. Sometimes working in a more clear environment, having an area that is where I don't have all my cables within a 4-foot range, stuff like that. And finally, we'll talk a lot about cases and stuff like that. Scanning the items before you put them in the case is a way that I don't have to increase the power so much that now I've got a new problem. Scanning items after we remove them during return is a way to not have to increase it so I can get it more contained. So again, that really, I want to push back because we have so much hope and desire of, I just want RFID to solve my problems. I don't want to change any of my processes. It should magically do all my work. And it doesn't. It has best practices in how you get things done, but sometimes you do have to challenge your thoughts and say, just because those cables end up in a case doesn't mean I have to wait for them to be in the worst possible area to read them and get accurate results. I can grab cable, scan 50 of one type of item and put them on a case. And just like I wouldn't scan those barcodes after I put them in the case, you can still get the bulk speed effect of reading them before you put them in the case. Why put them in the worst possible read environment and expect perfection? And I know people want that, but you're setting yourself up to get less than ideal results. And so I just want to push back on that and say, how can we get the best results, not how do I want to make it easiest on me and expect it to work, even though it's the worst possible scenario. So I want to push back on that, and we'll talk about that and things like that. So how we handle cases when we're emptying cases, it's going to go through a QA process. You should be cleaning those. We should be counting those. We should be looking at our manifest. Just because we could scan them in the case doesn't mean you're going to get them all, and we'll talk about that in a little bit. So finally, last little bits that we're going to talk about the specific tags, just to kind of understand it and clarify things. On a tag, there is a specific structure of an RFID tag. In this bottom middle item, you've got a barcode layer on the top. In between, you'll see that copper little square line. That is the antenna that will harvest the RFID power. In the middle, that antenna is connected to a chip, and that RFID tag is going on top of an adhesive. So typically in a label, you're having a top layer, which would have the protective film, a barcode. Underneath that, you've got the RFID tag layer, and then underneath that, you will have the substrate or the foundation that all that is connected and adheres together as one label. So that's what you're looking at when you look at RFID tags and labels. The picture on the right is an example of certain labels are meant to be put on or off metal. And so in this example, there's a metal film right below or right inside of the label adhesive. And so this is a layer that is meant to be put. The label works on both metal and non-metal because it has its own kind of metal substrate underneath of it. And so it won't affect the tag, whether it's put on either type of material. And so that's the components: antenna, IC chip, and then what's on top of it, what's on the bottom of it. These tags that we recommend are what are called passive UHF tags. So passive UHF tags, no batteries required. They're getting their power from the reader. That means they're lower cost because you don't have to put a tag into it. It usually means they're much smaller. They don't have to be as thick. So it's a lower cost than an active tag. There is no shelf life as far as, unless you break that antenna or that IC chip, as long as you have RFID power, that label will work indefinitely. And the main thing to also understand is that tag is inert. It is not doing anything while RFID isn't present. If you put that on a radio belt pack that's in the 400 megahertz range or something like that, the power that's needed to activate and harvest and turn on that IC chip is in a very different frequency range. So just because I've got this range and a wireless microphone range, when it's near, when that belt pack is turned on, it's not activating that chip. So those are RFID passive UHF tags. So example of labels, it's the most commonly used cost-effective form of UHF tags. They are designed for both non-metal and metal tags. And again, smaller the label, typically the smaller the read range, but depending upon what you are tracking, sometimes you need something smaller to hide it. That may decrease its read range compared to a different label. So larger the antenna, the better read range and the tolerance. So I said we talk about this, and when people talk about RFID tags for cabling, that is one of the most common areas that people are trying to tag. What the history of this setup is, there is a company called Vizinex back in the days, they created specifically IC chips that had the RFID tag embedded in them. And those tags were designed to be put on insulated wire cable. They were tuned for that. This wasn't a let's got a chip that works really good in the medical range or on the tools and put it on here and hope it works. This was designed for cables. Then what they did is they took some industry housings that already were being used and made these tags able to be put into these housings. These housings have different diameters, typically starting at 1/3 of an inch, going up to 1/2 an inch, and continuing on. So some examples of these tags I'll show you. So it's a little PC chip. Manufacturers can print different logos, human readable barcode identifications, 2D identifications, all sorts of stuff. They will take that and put a label on top if you want. That gets dropped into these housings. So these housings typically have a top and a bottom that can go around the cable. The tag goes on the inside in a very specific area, and they are screwed together. There's an area inside the tag where you can put tie line through to captivate that. You can typically get these housings in different colors if you want. So if you're trying to do color coding on your 10 footers, 25, 100 footers, you can get the same housing size in blue, green, yellow, red, black, whatever. So in this example, this is the smallest housing that they make. It's for 1/3 of an inch cable and smaller. They have added a little bit of a angled relief. So as you're pulling things through, it's not getting stuck on hard edges. So that's for Cat5 cable, XLR, DMX, small diameter cable. And it goes up from there. This is an example of a 12-4 AC cable, SO type, so a little bit larger for that size of a cable. We continue to increase here. This is 4/0 feeder cable in a higher diameter opening. And then I believe this is one of the largest. This can hold multi-cable. If you've got Y cables, twofers, things like that for larger cables, it can hold the highest diameter. Again, the same chip is on the inside, and it's just the housing that is changing that. The great thing about this is it does have a really good read range and is optimized for this. So Vizinex got bought out by a company called HID Global. The beautiful thing is HID is a global company. They also are one of the first companies in the RFID worlds that has a AV specialist. I know that doesn't sound groundbreaking, but it is so hard for the RFID world to comprehend our industry and how it's used. And HID has invested in products and people, and I can't recommend them enough. Lisa Moore is a great asset from their team, and we will get their information. But they understand our industry. You don't have to translate stuff like that. I've been going to RFID trade shows for a while. I'd go up and talk to different vendors. They try to understand what we're trying to use. And the best thing I could do is point up to the ceiling and say, see that truss and those lights that are lighting your booth and things like that? That's the stuff we're trying to track. And they're like, huh, that's weird, stuff like that. So HID is a great company to work for or work with. They work really well with our industry. They also have specific tags. There are other vendors that are great. I'm a little bit biased. HID is a great company to work with and very responsive. There are other sorts of tags that work really well. This is meant specifically to work on fabrics, drapes, linens, things like that. It's a flexible tag. If you look at it, you can actually see the wire that is that antenna that is connected to the center little black raised area. That's the IC chip. So it's kind of cool to see and feel that stuff. But this can either be sewn into linens, costumes, drapes, or ironed on, or other functionalities to attach it to linens. There also gets to be other types of items. We've had people ask us, how do we track small metal items like screen cranks? This is a very specific type of tag. It's a miniature item, but yes, we can read that tag. It is meant to be put on metal, and it gets okay read range. We've had some rigging companies, when we talk about items being damaged and impact motors with chains and hooks, those are not delicate items. Your riggers, your local union are not going to be worried about your RFID tags on your motors. So there are specific tags that are designed for that to reduce the impact. These are designed more for people that are doing maintenance on things. So they actually optimize these for a shorter read range. So we're not reading tons of motors and things like that. But it's a very specific example of a tag for a specific industry usage. One of the couple of the last ones, the really hard items. I have yet to find a great tag for handheld microphones. We have played with countersinking these into the material there. I don't think you're going to want to take every single item and put a tag in there. The closest one that I have found in this industry, it was designed for medical instruments. It's designed to be on metal, and we've literally taken it and epoxied this tiny little straight lip of an item. And so that is a way I played with RFID on handhelds. To be honest, the easiest, most cost-effective way is still 2D barcodes. Inside there, there's a tiny little third of an inch or a quarter of an inch circular 2D barcode. We sell those to our end customers. We buy those in bulk, and a lot of people will buy 200 of these at a time and put them on the inside of their microphones. Another little interesting ones that we've talked, a lot of our customers do festivals and stuff like that. Cable ramps are very hard to track. They put on a special coating to make sure nothing sticks to it. So if you put a barcode on it, it doesn't stick as well. It gets muddy. We got to clean it. This is the cutest little printed cable ramp. And in there, what they did is they ended up basically hollowing out a little area and putting an RFID tag on that. And so,
hey, Chris, we're at about 4 minutes left, so just wanted to do a quick time check.
Oh, we got lots more to go over, but yeah, sorry, we got lots of data and stuff like that. So that's the area that we get into with RFID and tags and stuff like that. Okay, so readers and where we've come and gone with readers, things like that. Sorry about that. So we've gone through different iterations. The RFID 80 from Zebra was Bluetooth only, $1,800. RFID 40 was an update of that in 2021. It had dual triggers that you could do both barcode and RFID reading. It was still Bluetooth, but it was an improvement, better Bluetooth speed. Over the last year and a half, we've been working with certain customers, and they've been implementing RFID 40s with putting an Android device specifically connected on top. This was a great improvement because we got instantaneous read speeds on it. The downside is it was expensive. It was about $3,800 for a setup of that. So the new FlexScan Pro is a device that we have been recommending. It is an all-in-one device, so it's not two pieces connected together with a sled. It can do both RFID reading and barcode scanning. It has the most RFID power in compared to the Zebra. It goes up to 33 decibels. It's got an instantaneous read speed, and it's got a tag locator functionality built into it. And we are selling these at $1,200 with a drop-in sled charger. And this has really been a game changer for the industry. So it's a 70% hardware cost reduction, and people are starting to buy these on scale. So back when we were selling the RFID 40s with the TC22, everyone was buying one of these to play with, and that's all that they would kind of max out on. And they were more like specialty tools, but the cost was really high and prohibitive from really scaling. The full integration is much more stable, much more user-friendly, and dramatically less downtime. The RFID 40 and the TC22, we would, every so often, customers would change some settings, and it was extremely hard for them to look at all the different settings. And every so often, hey, send it back and I'll reprogram it for you if you can't go through our specific setup documentations. We've had people work with these, change the setting by accident, people fiddling around, and it's just much easier to reconfigure. And so the difference with this is we have sold more of these in the first 2 months of 2026 than we sold of the TC22s and the RFID 40s all of last year. So people are starting to buy these in bulk. Other interesting things is we've got customers who are starting out Flex journey, starting out their trial, and they're starting out with RFID in the trial. This is no longer an enterprise only limitation. And so when I say that, we've got customers who aren't these large, massive warehouse companies that they want to start out with RFID, and they're going down this process. So this is helping this to be more attainable and more scalable. So when we talk about that and implementing RFID and stuff like that, I want to talk about RFID and cost savings and how this usually works and what it really means. So we took a kind of baseline warehouse salary at about $20 an hour. You know, it'll go up and down depending where you are, things like that. But at 1,000 scans, typically about 6 seconds per scan, that'll take you about an hour and 40 minutes. That equates to about $33 in labor just to scan those assets out. That same process, we're doing the reads, reviewing them and going through them and scanning it. We can typically get that in the 5-minute range, which equates to about $1.33 to read it, review it, and process it. So that's 20% faster. That's a 95% reduction in labor costs. And the main thing that I want to talk about that is this really allows your team to focus on more important processes. We can finally get serialization and get that scanning done faster with RFID and allow your staff to focus on more important QA process, prep process. We want to make sure those jobs are prepped and ready to go. And so you're not losing money on just scanning and not being able to concentrate on bigger things. So with that, I'm going to go into my system and close. And I'm going to share my screen.
I know we're a few minutes over. If we can steal 3 to 5 more minutes of your time, we can finish this up. So thanks everybody for your patience.
Yeah, I hope it's good information. Um, so I'm going to stop sharing on my screen. Okay. So in theory, when things are coming in, we can do warehouse scanning processes. And so I'm over here. I've got a bunch of tags 5 feet behind me on my app. I'm going to go to free scan in, go to RFID mode, and I'm going to read all these items. Again, you saw me move a little bit, change the polarization. I can review these items. I've got all these XLR cables, some of these chain motors, some of these that tiny little metal tag, my twofer motors. So I can scan all those items in as an example. If I need to go on to the next one, I can do a new scan and start to read that. So that's part of that free scan in. Again, if I had a trunk load of stuff, instead of reading it while it's in the truck, a lot of times we're going to want to clean that stuff. We're going to want to count it, make sure we get what we're getting. It's not too hard to drag those out, read it. You're isolating stuff, working in small incremental processes, but still getting the speed of the RFID. In this process, if I need to go and prep a job, I can go to this job. Oh, wait, sorry. Before we start that process, we've returned stuff. One of the functionalities that I like to do is do the container builder. This is where if I've got a case that needs specific items inside of it, before we put it back on the shelf, container builder allows us to do that. So if I scan this case, I didn't return all those items. I'm going to remove the contents as an example here. And it's showing me that this case should have 8 LED tiles in it. I can now go to my reader. Oops, I think I put one of those tags in the wrong case. That's the beauty of this. I was expecting 7. It didn't have 7 inside of it. So I'm going to put that in there. Now I've got 8 tags. That's what I was expecting. Let me review it, make sure I got the right 8 tags. If I got something extra, I could decheck it and scan that in. This case is now complete, and I can scan the case to close it back up and scan the next case and rebuild that. From here, if I were to go and prep a job, I've got audio cable with some XLRs. I've got some video that needs 8 LED tiles. I've got some lighting that needs a bunch of AC cable. And there's going to be some shipping cases that are coming with this that I put into this job. So in this example, without having to take this case and open it up, because I've already pre-packed it, I can just scan this case and it's marking my video there as fully prepped. Functionality, if we want to put stuff in cases while we're building the job, I can scan a case. That's a free pick container. I can go into RFID and read the contents. I got these 16 items. I can review that, make sure I got the right 16. If I want, I can keep adding more items to that same case because we're still in capture mode and free pick container. So I could do a new scan. So these are these 50 tags that I've got here. I can review it to make sure I got the right ones. and scan those. And then I'm going to scan this last cable ramp as an example. Read that. Again, with Flex, I highly recommend having those pictures. It really helps. I'm going to close that out, and we are now 100% done. I can close that case, and I can mark that as finalized, and that job is ready to return. And as an example, final thing when that comes back. So that job, if I wanted to return stuff, I could go to the return screen and start to scan all those items in, or I could do pre-scanning. So that's a little bit of functionality with RFID and how we use that in the mobile app. Other things that's really great about this tool, I'll show you some of the settings. This system has how do you want to configure your RFID, and it has how do you want to configure the scanner. Those are two separate apps. In the RFID, it's called UHF. There is some settings here on how it's configured. There is settings here on parameter. You'll see at the bottom under basic parameters. Right now I'm at 25 dB. If I want to change that, I select that to change the power to say 26 and hit set. Process write successful. On the old RFID readers, the Zebras, we would have to go in and reprogram that. This is just built right into the interface very simply. One other area that's really kind of cool, I'll show you, it does have an inventory finder. I'm going to read all these cables here. This is basically showing you the raw data. It counted 51 items. And here it's showing you in the nums how many times it actually read the tag. And the RSSI is, that's the power that the tag came back at, that backsplatter. So you can, it's showing that they all came back a little bit different power. That's the polarization. If I wanted to find a specific item, I could go into inventory search and I could find the specific barcode. We might want to find that somewhere else. But let me see. I know this B one is the specific one that I'm looking for. Am I still sharing my screen?
Yes, you are.
Okay, cool. And so what that yellow point is it's showing you as I go away, that tag's behind me. And so, and it's actually vibrating on how close I am and things like that. So sometimes that's a tool where you can actually find a specific tag. If this was all these tags in a specific area and I knew its identification, I could use that to find the tag.
Chris, maybe is that a good spot to leave it? We're about 10 minutes over.
There's other stuff I haven't gone into portals and the things that we're going to, so that's up to you. So much information that we can go over.
Well, why don't we leave
Let's
it there?
open it up, and then anyone who wants to stick around for where we're going with portals, we can talk about that. So,
all
questions.
Right. I'm getting some general feedback that we should keep going. So
cool. Well, let's start here. So, questions about handhelds and tags.
sorry, Chris, we've got lots of questions.
Cool.
You know, just let's see.
Let's do maybe 4 or 5.
Let's see. Sorry, I'm scanning through here.
Give me a second to wet my whistle.
Do we need to dedicate a cell phone to these readers?
Nope. This is an all-in-one Android device. And so that's the beauty. The cost in these at $1,200 is you get the reader, the barcode scanner, the Android app device, and so it's an all-in-one. I had some customers asking, hey, can you recommend a really good barcode scanner for us? And the funny thing is, a really good 2D Bluetooth barcode scanner is in the $900 to $1,100 range. For $1,200, this is just as good of a barcode scanner than those, and it has the Android app on it, and it has RFID. And so, again, that's one of those areas where these new customers are like, I'm going to buy two of these instead of, because we're going to be on barcode and we're going to move to RFID. This is a very attractive option.
What's the battery life on the scanner?
Interesting. Battery life is really good. If you can see on my screen right now, I believe you're looking at that. On the top right, there's actually two batteries. There's a battery in the handle, and then the Android device has its own battery. There's a drop-in scanner here that when you drop it in, it's going to charge both devices. And typically people are using them, full time during the day. Everything is subject to change. If you're at 33 decibels, the highest RFID, and you're scanning constantly all through the day, you may overextend that range. But most people, I don't hear that they're not. I haven't heard anyone saying that they can only use them for half a day. Other thing that's really nice on the charger. So this is the drop-in charger. There is also an external battery sled area on there. So you can have a secondary battery charging on the charger. And I'm not going to take that battery out, but in the handle, there's a screw gun and you can charge there. Also, these are typical Android devices. So I'm using this on Wi-Fi. There is a slot here to put a SIM card in so that you can use it on the road without a mobile hotspot. So there is a place, I believe that's the slot right there where you can throw in a SIM card. Good drop ratio, good weather protection. They have been used outdoors and things like that. So I have customers doing some scanning from job to job that are using a device like this and doing the scanning kind of at, prepping at the loadout.
Let's see. I think this is possible, Chris, but is there a way to type in a specific RFID code you're looking for, or find a particular asset that you can't find?
So the UHF app is an app built by them. This is one of the areas that I don't like, and we've made a request for them to program this functionality. They're using this to read what's in the area and then select what you want to find and find it. I have made that request. I don't know where they are with that. Ideally, that'd be the perfect solution. A lot of people are taking unreturned items from a customer, using kind of going to that area, scanning it, and going through the list to find that unique. Oh, I know the last four numbers are 509. I can select that and find it. So it is not ideal, but it is still better than nothing.
Great. I think, Chris, we've still got a lot of questions coming in. There's a lot of interest over what you kind of covered and asked to kind of go deeper on that. A lot of questions about what tags we recommend for specific objects. I think it's probably best to leave it here, and then we can follow up with some of these around questions and answers.
Yeah, we can set up phone calls. I know a lot of people want to go more in depth and have very specific questions. We'll probably put a FAQ email afterwards and answer as many as we can. But yeah, schedule some time with us.
Yeah, I think I think we've got some pretty good requests here on kind of what a future webinar, just going kind of deeper on this last part, could be as well. So
okay.
With that, I know we've gone about 20 minutes over. I appreciate everyone's engagement. Like I said, a lot of questions here. We will work to answer as many as we can in our follow-up email, either later this week or first thing next.
Do we want it? I say we keep on recording. Whoever wants to head off can, but I'd love to go over kind of some of the RFID portal stuff that we've been experimenting with, if that's okay. You okay with that?
Sure.
Okay. Yeah, again, if you're not interested, don't listen. Okay, so there are two primary RFID reader categories. There's the handheld that most people are aware of, and then there's what's called the fixed readers and things like that. And people have been extremely enthusiastic about this is where it's going and stuff like that, and want to set realistic expectations. What certain customers have been experimenting with and what we found, and where we want to go with it. So in a fixed reader portal modality, there are readers and then there are antennas. So this Impinj Speedway Revolution 420 reader on the left, this one has four.
Chris, you're still sharing the
Oh,
RFID device screen.
I apologize. Let me go into Zoom and stop share. Perfect. And then uh, okay, and I am trying to reshare my screen. Somehow I have lost. Wait, there it is. Okay, sorry. It was back one layer. Okay, sorry about that. Okay, so back to full screen. Okay. So fixed readers. There are readers. This one has four different antenna coax connections on the back, has area for power, has different connections. Now, the typical readers have between 1 to 4 ports that you can connect to those. You can actually extend these and scale them more to have even more antennas connected to a single readers. These can have multiple communication methods, network APIs, serial connection, and even what we call keyboard emulation. These can either be powered by a wall wart functionality, but oftentimes the new modern ones are powered via PoE or power over internet. So a certain type of Ethernet hub, you connect it via Ethernet and that sends the power over. It is the common deployment method for a lot of the modern readers. So antennas, there are different types of antennas, and they all have different features and stuff like that. Just like the RFID readers in the handhelds, some antennas have different polarization, linear or circular. Ideally, in your antenna portal, you're not doing two of one type and two of another type. You're using the same for consistency. The readers and the antennas do not have to be the same brand, but again, consistently over the antenna is recommended. Different antennas have different connector types. So we've got one type of antenna that we've been connecting that has a smaller, I think it's called SMA connector, where another antenna has the same connector on both the reader and the antenna side. So just be aware if you're buying things to test, antenna and antenna connectors are a thing. Going back to the modality of how we are trying to use RFID, barcode was spotlight, RFID handhelds are more floodlights. I look at RFID portals as we're using a cyc light with a scrim. We're really trying to set a certain amount of power throughout the whole range of what we're reading through. And so typically in a cyc light, you got multiple lights overlapping, so you don't have any dead zones, no hotspot, it's smooth and even. That's really what you're really trying to create with the portal. The antennas, what's happening as you start to connect it and activating the read range or the antennas, what it's really doing is it's cycling through each of those antennas. So on an antenna that I have connected over here, you'll see a green light on the 1, green light on 2, green light on 3, green light on 4, and it's cycling through those. And what that's doing is it's trying to make sure that it's not phase canceling the different powers between these different items. So that's really what happens. RFID lingers for a little bit, especially in metal heavy environments or dense cable piles. So when you have these portals, that's really what's happening is a reader is powering up the different antennas and cycling as you're going through there. There's different ways that you can stack antennas and connect them. We've seen different people use different, and again, different industries, things like that. On this left image, this is a company called SLS that makes very specific dock portals. What's really happening there is that's got 2 antennas stacked vertically on each one pointed inside. So that's kind of a 2x2 stacked configuration area. But there's different ways. I've seen customer or different antenna manufacturers, and they're recommending offsetting everything so no antenna is pointing at another antenna again. That power lingers for a little bit, so as these are cycling through, it's still not interfering with one antenna towards another. That's another example that we've seen. Doing some testing at a specific customer, they had these interesting cases that I loved back in the days. These are meant for a lot of rigging items. So they've got a mesh metal wire on the outside of the case. That's basically a shipping case slash Faraday cage. And so as we were doing some testing with these going through, we changed the hang area of the RFID antennas, and we put 2 on top to point down and 2 on the sides, and that gave us a better read range with and better read accuracy with that specific style of case. And so that's an example. If you start to point down and you're putting these on a portal and you've got a metal dock plate, you've got to understand that metal reflects and things like that, and it detunes things and stuff. So every solution that you try to solve, there's different things that you create new problems. So putting the antennas on top, if you're putting them and pointing them towards a metal surface, understanding that will affect it, things like that. These antennas on the reader, you can control the configuration and things like that. And so in this example, I actually turned the antenna power on the top side pointing down high at 30 decibels, so max value, and it's pointing down into the cement and it's getting good penetration and things. The side ones, I actually turned those down so it doesn't extend that far past the antenna. So I'm kind of trying to clean up the area around it. There's also a setting for these readers called sensitivity. It acts like an audio gate where that RSI value that it reads is what's coming back. You can send a threshold that say it needs to be above a certain area or a certain power setting coming back. If not, throw it away. And so in this example, I had some tags on the other side of that portal or that truss, and we were able to detune it to kind of artificially throw away tags that were adjacent, so we had a cleaner environment. This is an example of a customer in Europe that I was working with. They've got larger dock doors, and they were building a portal that had 6 antennas, 2 on the right side, top and bottom, 2 on the left side, top and bottom, and 2 on the top pointed down. And they used an expansion tool to get that into the same reader. Other areas that you talk to, oh, I want to turn it up so I can penetrate these cases. Great, we've solved one problem to try to penetrate cases more. is this starting to extend past the area that we want? And maybe sensitivity isn't the value that we want to use. This company ended up using a very cost-effective barrier. And so if you can see on this slide on the right, this is using actually chicken wire, and it's acting as a Faraday cage to limit the RFID extending out into the warehouse for nearby reads. And so there are also tools that we have called RFID mappers, where we can literally map the power in different areas. So this is me on the other side of that portal behind the chicken wire. And as I go outside that area, that bounce that you see, that's the different antennas at different power ratings that it's coming. When we go back out, you're in the 40 to 60% read. When we go inside that portal, it's max volume. Back out, it's going down to 20 to 40. And if we go behind the Faraday cage, back down to 0. So it's a really interesting tool that you can use to start to understand RFID and the power, and how to balance power and containment. Things we haven't liked a lot in the past is the modality of, UPS works in a modality where I know that this portal is reading everything into this warehouse, and it's kind of a walk through and go. No one's monitoring it. The data is being streamed somewhere else and is being processed in the background. And it's really optimized for a single purpose and a speed. And so again, think UPS or Walmart. All the tags are coming in one area, and it's not monitored, and it's just being processed in the background. That's one of the reasons why we haven't really worked in RFID portals, is that modality really doesn't work in our industry. What that leads to is there's no accountability for who's doing what, because we're moving in and out and around things in our environment, and it's not just everything goes through a conveyor belt and reads and comes in. That accountability is really important for us, and we need to understand that there's a high risk of over and under scans in our environment. Every case isn't cardboard, and every cardboard isn't have a label pointed up in a reader at a specific range. And so those are some of the things that really have struggled as we've started to explore this in our environment. And so we don't want to sacrifice accuracy and accountability for speed. Our customers want 100% accuracy. They want to use it and leave everything in the case in these dense environment. But what we've really found is you're still getting about 75% to 90% as you walk straight through. We validated this with other customers in the industry, not on Flex, writing their own products and implementing RFID, and they're getting similar read results in this environment, where they're trying to put cases through with cables through a portal and going straight through and not stopping. And so it's something that we're still trying to figure out how we do that. What we really want is to continue just in the mobile product, reviewing to make sure we got what we expected. The ability to remove stuff if something came through that we didn't want to process, and the ability to reread it and get the good quality. We need accuracy and accountability over prioritized raw speed only. So we do have customers that are actively testing out RFID portals. They're using different hardware and things like that, but they're working with implementing that and feeding that data directly through Flex, through different things that we've done. Some are using it with the mobile app, directly injecting it into that. We've got other people who are playing with APIs and things like that. But keyboard emulations allows us to start to inject that data into both the Flex mobile app, and we've been doing some work in our Flex 5 desktop as testing environment to see what might it look like in the future in desktop, as we start to figure out how can we get these portals to work the way we want them. This has opened the door for us to really start to test and experiment more than we ever have. Again, tag polarization is a very real thing that affects read accuracy. Tag dense environments is a very real thing that affects tag accuracy. Things that we found to work through things is rotating these inside that portal zone for 5-10 seconds does actually help us get that extra 10-15%. So we've done testing environments. So finding that sweet spot and putting a process in place to counteract the density and polarization through turning and spinning really helps. Is a way that we've started to experiment. So we've done some experimenting with customers. This was 500 EtherCon tags that were put in a large bin, and we took flex out of the environment. Can we get 100% read mode? When we started to take these and walk through them really quickly, unloading a truck, not stopping, that modality gave us that 75 to 90% read range. In this testing environment where we brought those portals close by, we angled them in, we found a little sweet spot, and then we did a slight little spin on this. All we're doing is reading tag data. Did we get 500 unique tags? And once we did that kind of a little bit more than 360 range, we got all 500 tags. So we're starting to find what might functionality look like in our horribly designed workflow and packaging and stuff like that. So how do we counteract that 70 to 80%? Well, it might not be just walking off a truck. Maybe we put this in a clean area, in a free scan in area that may be more contained, but that is an area of what we're looking with to make that work. My takeaways are still handheld RFID scanners are the most affordable and the most versatile starting point. Those readers with the antennas are in the $5,000 range for 4 antennas and a reader. I can get 4 readers and have 4 people scanning independently for the price of 1 portal. Oh, you want to put a portal on every dock and you got 5 docks? That's $25,000 investment for less than ideal results. And I'm not trying to dash anyone's hope. I'm trying to set realistic expectations. And so my takeaway is handhelds are still the best thing right now. They are cheaper than ever to deploy, and we can scale those. Later, we're going to be working on portals more. I might have a specific workflow area, but to me, I'm very headstrong with RFID handhelds. They have increased in their usability and in their price. And I would rather have 4 RFID readers that 4 people can use instead of investing all my money in a portal right now. Other things that I would think in the future, there may be working on 2-step. We may go through a portal, then it goes into QA, gets cleaned, and before we put it back on the shelf or back in the case, we rebuild that with the RFID. Those 2-step processes might get your inventory returned quickly with a portal with 90% and get caught. Anything extra gets caught during a secondary return or a rebuild or in prep quantity, things, stuff like that. So we've gone over, but wanted to kind of talk about all things RFID. If we've got specific questions about portals, let me know. We will also be doing follow-up on that. I know we've gone way over. I hope this has been good information. Jason, where do we go with this? Do you got specific questions you want to forward, or do we?
Yeah, I mean, we've got loads and loads of questions we can answer, Chris. So I
Let's
think we
do
should
a
kind of
couple, and then we'll do the rest with an FAQ. How about that?
Sure. Can RFID be used with inflex for both serialized and non-serialized items just the same?
What was the word inflex?
Yes.
Oh, okay. Read that one more time.
Within Flex. Can RFID be used within Flex for both serialized and non-serialized items just the same?
Yeah, so typically when you're talking non-serialized, you've got a bulk quantity. You're typically going to use that with a in this warehouse mode over here on the left. If I'm returning, I'm counting all the cables. If I'm returning 50-foot XLRs, you might have a barcode cheat sheet that says I'm going to scan the barcode and do a free scan of quantity 50. We can do that in Flex. Other people will have, if I'm on the manifest and I'm counting those, I go to that line item, click it, it'll ask me for a quantity. And yes, so Flex can work with non-serialized, and that's a quantity that you're putting in. Flex can work serialized with both barcode and RFID. Yes.
All right. I think, yeah, probably best to leave it there, Chris. I've got a lot of commentary, so I think it's best to probably take it offline and kind of circle back with everybody on a Q&A and some potential follow-up webinars as well.
Perfect. So we can, if you're interested in these scanners, we typically stock at least 12 at a time, but they do come and go really quickly. We sell these both with a tag package that will have both uh, 4 different types of labels that we send out, 2 different types of these cable tags, 10 each of all of those, and we send out a scanner, 1 scanner or more. We can both rent and purchase these scanners or sell those scanners to you. And so email sales@flexrentalsolutions.com if you're interested in buying a starter package to get going with your system. And schedule some time if you got follow-up specific questions. We will be at NAB on the 19th through the 22nd. We will have both RFID scanners and a portal setup. We will be at Second Warehouse is doing a demo of their sub-rental marketplace at Rock Nashville on the 20th or 21st. We will be there supporting them, and we will also have some RFID packages out there to play with. So if you're interested in that, send an email to us and we can make sure you're on an invite to come and attend that at Rock Nashville.
Well, thank you again, everybody, for your extended time and your engagement throughout. We'll be following up with, this recording as well as some answers to your questions and some
Yeah, and
follow-ups on the
it goes
events.
to tell you how excited people are about RFID, that they want to spend the time and get the knowledge. I hope you understand how passionate we are, and that passion is offset by how do we make sure this works and setting realistic expectations and explaining the nuances instead of RFID works, get it, and then you get it and it sucks. We really want to be your partner on this. We don't want to be snake oil salesmen. We really want to make you get to that process and get real results that are repeatable and isn't just something you buy and throw away and never use. Sorry, Jason.
Awesome. No problem. Thanks, everybody. We appreciate you joining, and we will see you again soon.
Thanks everyone for your time, and we really appreciate it, and let us know how we can help.
Bye-bye, everyone.